Alright, so let's focus now on this problem of understanding matrices. And for quite some time, I will limit the whole discussion to algebra only. Because it is exactly the power of algebra that allows us to continue. And I will use the full power of that. And I hope to get complete understanding of algebra of matrices before I try to bring that understanding to physics or geometry. I will primarily be interested in physics, because I hope you are primarily interested in those flows. So, well, speaking of tools, what kind of tools do we have? Well, basic algebra suggests two very simple tools. And now you can see how much algebra even suggests. The tools are addition, and we basically all know how to add two matrices. If you have one matrix and another matrix, well, adding those means adding individually the corresponding components, the corresponding entries. So addition of matrices and multiplication by a constant, when you can see that each entry has, well, is equal to that same constant multiplied by something, you can factor that constant. Or alternatively, you can multiply by a constant by bringing it into each entry. So those are very simple intuitive notions, and those will be enough to carry out most of the computations for us. This is the only thing we will use. But we will need some ideas. So now the trick is that I will now do some thinking. And remember, there is no way to do thinking in algebra. All right? I mean, the whole thinking will happen in the world of geometry. Well, hopefully geometry is very familiar to you. But the thinking will suggest some computations. All right? So that is the most interesting and, I think, advanced part of mathematics, when you learn how to think one way and do something else, something totally different at the same time, so that the thinking suggests your action. So what are we going to do? Well, first of all, we are going to think about a matrix in a new way. So algebraic way of thinking about a matrix. What do you think algebraic way is going to be? Well, a matrix, algebraically, is just a bunch of numbers. M11, M12, M21, M22. And there is no thinking associated to it. So, that's the first step. Forget about any thinking. All right? Leave all these meanings behind and think of quadruple of numbers. Now, have you ever thought about a quadruple of numbers? Probably not really, right? Now, let's simplify the problem. Have you ever thought about a triple of numbers? Have you ever thought about a triple of some numbers? 1, 2, minus 7, like this. Well, you did, right? And what did you do? How did you think about it? Well, you thought about it as a point in 3 space. You might have thought about it geometrically. Either about a point, or as about a vector. And you can change those thinkings, right? So, now we are doing the same thing. Okay, so this is quite important part of the whole story, right? I'm telling you how to think, and the thinking is either to treat this quadruple as a point in some 4-dimensional space. Right? It must be 4-dimensional because you have 4 coordinates. Or you may also think about it as a vector I will use these bracket notations just to think about a vector, again in the same four-dimensional space. All right? And now, thinking about vectors, we have some tools to work with vectors, don't we? Geometry suggests that for any two vectors, or for any one vector, you might ask for a magnitude, right? For any two vectors, you might ask about angle between those two. Would you ever ask about an angle between two circulations? Or an angle between circulation and expansion? Well, never, right? But so we will. And okay, sorry, I will leave this behind. So, how should I think? Well, it depends on what I want, right? Now, what I want is, I want to understand all those matrices. Speaking geometrically, I want to understand all the points in that four-dimensional space. So how can I do that? And what can I use to understand those? I can use addition and multiplication. So I would be happy if I can choose some very basic, very simple things like vectors, and if I can explain or express any other vector in terms of those. So geometrically that amounts to choosing a coordinate system. Right? So that's the first thing you do in engineering, don't you? If you want to bring some numbers, you have to choose coordinate system.